Hello, today we will make a final project presentation for you. The name of our project is Light Source Target Mechanism. We are carrying out this project together with our project advisor Cüneyt Yılmaz. Our project team consists of me, Ayşe Simay Yalçın, and my teammate Bengüsü Aydın. The primary topics listed on this slide will be the focus of our discussion today. The problem we addressed when starting this project was security. Crimes that take place all over the world at any time endanger everyone's safety. In our project, we aim to target light source in dark environments with light sensors. These are the motivations we had when starting to design this project. These can be listed as you can see in the slide. The system flowchart was created to illustrate the workflow and processes. First, the controller receives information from our sensors when they spot a light source in the shadowy region. By comparing the information from these sources, the controller determines where the light source is located. The actuators are then sent a control signal. By communicating the motor's position information to the processor, the motor encoder establishes a closed control system. The area can be observed using the camera at the end of the pan-tilt mechanism when the motor rotates in the desired direction.
For an innovative and reliable system design, as a result of the researches, we determined the market requirements in the last period. Then we revised the system requirements to meet these market requirements in accordance with the changes made. The most important change in this slide is that the minimum lumen values that the sensors can measure are more realistic. The biggest inaccuracy we made during the design of the mechatronic system was that we calculated the lux values based on a square meter area. After calculating surface area of the photoresistor, the minimum measurable light intensity from a distance of 10 meters was calculated as 30 lumens. You can access the application we use as a calculator with a QR code. To get the equations of position, 3 sensors were placed on a single axis, and their current values were compared with one another. Then a formulation was made by associating the location of the light source with the distance of the sensors from each other. In order to find the position on the y-axis, we decided to place 3 sensors in a theta angle with the x-axis. We compared the information received from the 3 sensors were placed, as we did for the x-coordinate, and found a new x value. When we intersect the line perpendicular to the values of these two x values on the coordinate plane and pass through both points, we have found the left x value and y value. After these calculations, we have decided on the geometry of our system. As you can see on the slide, there have been changes in our mechanical design. Unlike the old design, 2 new bearings have been added for pan and tilt movements. In this way, it was desired to provide a more balanced load transfer. The upper parts of the tilt base were made mountable with screws. Thus, the problems are prevented that may occur during the assembly. In our component list, you can see the standard screws and bearings used in the new design. On this slide, you can see the final technical drawings ready for the 3D printer.
Then we made the electronic hardware design of the system we designed over Proteus. We test the algorithm of our design by uploading code to the microprocessor with Proteus. We do simulations. You can see the electronic parts that we selected on the table. To achieve the most realistic outcomes, we designed our system in the Simscape environment. Figure shows the Simscape representation of our system. Next, we added PID control to the system in Simulink. The PID controller's MATLAB model is provided here. Due to the change in the mechanical parts of the system we designed, there was no change in the control model, but there were changes in the coefficients of the PID controller.
After the mesh analyses were completed in the ANSYS program, von Mises analysis was performed. You can see the maximum equivalent stress in megapascal on the left. On the right side, the place where the maximum total deformation is seen is determined as the bottom of the camera. According to the 3D filament material selection, a deformation not exceeding the yield stress was observed. The engine torque analyses according to the renewed mechanical design appear in the graphics. Between the 0th and 4th seconds the upper motor moves, and between the 4th and 8th seconds the lower motor moves.
Then, in order to verify the precision of the position equations we developed, we put up an experimental setup. In this configuration, 3 sensors were put on the same pathway and wired to an Arduino. Using position equations, we compared the sensor voltage values flowing into Arduino and discovered the X values. You can see these values on this slide. When we move the phone flashlight from left to right on a straight line, the position value changes simultaneously. These values prove that it is possible to find the x-coordinate of the location of the light source. On this slide, you can see the volt values of the A, B, and C sensors, and the x distance that occurs in these cases, experimentally and theoretically calculated. The correlation graph and coefficient of these two values are also given. The fact that the correlation coefficient is so close to 1 indicates that as one variable increases, the other increases proportionally.
The expected total cost was determined around 6,000 Turkish liras. We used the Trello application in order to be able to work with a realistic work schedule, to follow up efficiently, and to progress with the modern methods with multidisciplinary teamwork. We have arranged the task packages in our timetable in accordance with the design and production steps. That brings us to the end. We look forward to answer your questions.